Okay, I think we're happy. All right, Solidcam. So we're going to move into a CAM software, computer-aided machining. So let's talk about that. Nearly all conventional CNC machines or NC machines, that stands for computer numerical control or just numerical control, they take a program and they drive the motors that move the tables around on regular machines. So in the past, people moved the tables and the cranks. The computer will now drive motors that move the cranks. That's called NC, an NC, numerical control. Almost all of them use a standard programming language, and this is worldwide programming language called G code. It's a set of conventional codes that everybody can use, that all the NC controllers can use and understand. I'll show you some common G codes. All right, so here's what G code looks like. So, for example, if I send the controller a G code of 00, you're telling it move as fast as you can go. G1 is move in a straight line from point A to point B. G2 is do a circle. On and on and on. Then there's these things called canned cycles. So you can numerically control a drill bit and say, go from 4 inches down to 0 inches. Then go from 0 back to 4. Then go from 4 to negative 0.1. Then go from negative 0.1 to 4. And keep doing that on and on to peck, to drill, right? Canned cycles are like a subroutine in code. And it says, okay, instead of pre-programming every single one of those moves, the controller on the machine has a pre-programmed routine, and the G code will just call the subroutine. So the G83 code here calls a peck drilling cycle. Now the problem is, in order for this to work, the controller has to have that subroutine in memory. Some controllers don't. Most do, but some don't. In fact, one of our machines doesn't. Wolf Creek in the corner. So in that case, when you write your G code, you can't call that subroutine because the controller will ignore it. It'll say G83, I don't know what that is, so I'm not going to do anything. All right. So your CAM software needs to be set up knowing what controller, what machine it's going to write for. So if it writes for a machine that does not have CAM cycles, then it needs to command every one of those drill moves. If it's writing for a machine that does have that subroutine, it just calls the cycle. Okay? And that's what the CAM, one of the things the CAM software does for you. They have other things called M codes. I think the person that invented this called G code, I think they meant G for go. So go in a line, go in a circle, go do this, go do that. And M codes were machine codes. So these are all the codes that tell the machine to do something other than just move around. Turn on the spindle. Start the program. Stop this program. Turn on the flood cooling. Those sort of things. Okay? There's other kind of codes. So let me open you up. I'm going to show you a program. Here's a program. And this is actually one of these QB50 parts. If you read this, the name is kind of one of those QB50 parts. So this is a program that the controller accepts to run a part. Let's look at a couple of other different codes. You've got T codes. What do you suppose that's for? What's that? Not quite. You're close though. Tool. This is calling for tool 1. Give me tool 1. So in a machine that doesn't have a tool changer, the operator, you, has to put tool 1 in. Okay? On a machine that has a tool changer, it'll go to the tool changer and index to tool 1 and then put tool 1 in the machine. Okay, so you need a code to do that. Rapid. G54 is a work coordinate system. We'll talk about those more later. And then your parameters, X, Y. So this is saying really fast at this work coordinate system in absolute coordinates, go to X.314 and Y 1.1093. Then S. What do you suppose that's for? Spindle speed. So the M code says turn on the spindle and run it that fast, 3,500 RPM. Okay? You've got your X, Y, and Z coordinates. Let's see what else there is. Here's a canned cycle. This is a drilling cycle. So it's a PEC drill. It's going to drill the hole at this XY coordinate. It's going to go to a depth of 90 thousandths into the part, negative. It's going to retract by 0.1 every PEC. And it's going to do an F code, which is a feed rate code. It's going to move at 7 inches a minute. And then it's going to go do that same drilling at that coordinate, at that coordinate, at that coordinate. It's going to drill 4 holes. And then it's going to cancel the cycle. And these are probably turn off the spindle or some things like that. Okay, this is G-code. When I was first starting, they did have G-code, and they had very simple numerical controllers and C machines. We had to write our own G-code. We typed this out into a notepad file and then loaded it into the machine. Can you imagine the errors? Right? You do one thing wrong here. You fat finger this and make it 70 instead of 7. That sucker's going to go bam right into your part. Okay? Or you just have errors that the controller just can't understand. So this was very difficult to do, especially for machinists who typically didn't go to college. Okay? They had to learn how to code. So typically they'd have engineers writing the code. Right? Somebody figured it out that this is dumb. We have computers for this. So this is where they came up with CAM, Computer Aided Machining Software, so that you don't have to write this anymore. You're going to write off of your graphical interface, your GUI interface, and the CAM software is going to use a post processor, which is just a program written in something like C. It's going to take what you did visually and turn it into this code for the machine. This is what the machine understands. So it's your language translator. All right. There's all different kinds of CAM packages. As you can imagine, there's a market, so people get into the market. Probably the most famous is Mastercam. We've used Mastercam for years. ITL uses Mastercam. This last year we went in, we changed to Solidcam. Literally in the past couple of years, few years, they have changed from, you used to have a CAD program, SolidWorks, and then you had a CAM program, let's say Mastercam. You would build your part in SolidWorks. You would import your SolidWorks file into Mastercam. You would write toolpaths on it, and then you would send the G-code file to the machine. So it's kind of this 3-step thing. If you ever had to make a change in your part, you'd have to go back to SolidWorks, change the part, re-import the file into Mastercam, rewrite the toolpaths, generate the G-code, send it to the machine. Somebody figured out that's dumb. Why don't we just integrate the CAM package into the CAD software so that it's all one big package, and then when you make a change in SolidWorks, it auto-updates the toolpaths. So that's what they've done literally in the last couple of years. Mastercam just came out with their version of this last year, a few months after we switched to Solidcam, so we could have stuck with Mastercam, but we went with Solidcam. We feel like it's pretty good. I think it's about comparable to Mastercam, but I think it's a little easier to understand for somebody that's just picking it up. Mastercam's a little quirky. You have to kind of know it. What you'll see is when you have Solidcam, when you open SolidWorks, you get two more tabs. You get Solidcam Part and Solidcam Operations. Now, you guys were supposed to download Solidcam. Did you notice these? Anybody notice these when you open your version of SolidWorks? Okay, there they are. So you've got your Cam Part and your Cam Operations, and it brings up different toolbars, which we'll be using heavily. Okay? If you haven't downloaded it, it's time. You need to do it because you now have your assigned part, and you are going to be writing toolpaths, and you're going to be machining these parts as soon as you want to. Probably tomorrow or Thursday, you should be starting something. We'll walk you through the process a little bit too. All right. A few more minutes. All right. I'm going to open a file. We're going to start looking at Solidcam. All right. This is the bottom plate to the CubeSat walls that you're building. We have a version of this, and we're going to use it to bolt your pieces that you make together, kind of as one little part of the answer key. So this is the bottom part of that CubeSat. So let's take a look at the Solidcam environment itself. So you've got two Solidcam tabs, and you've got all these options that go with that toolbar. When we write a program, you'll also get another tab here, right here in your feature tree manager, and that's going to be very similar to your feature tree manager. Instead of having features like this, it's going to have toolpaths, and it's historical, just like your SolidWorks parts. So the first one you write is the first one up. You're probably not going to use the Solidcam Part tab. You're going to use the Solidcam Operations tab mostly. Tonight I'm going to have you watch the first of the Solidcam video tutorials. They have like 30 or 40 of them. There's 4 main ones that get you started with Solidcam. You remember with the SolidWorks tutorials, they're fairly good, but they kind of just click you around and show you what to do. They don't really say why. The Solidcam tutorials are even worse. They show you what they're doing, but you have no context, and they really don't explain why. But it's still good just to see the features. So I want you to watch the first one of those. And where do we find those? So if you go to I believe it's in the syllabus. So if you go back and look at the syllabus, which I know no one does, here we go. In the syllabus is the Jumpstart Series. And it's part 1, creating a cam part definition. Okay, watch that tonight. In the next segment, we're actually going to start doing that, but I still want you to watch that video. Break time.
This computer doesn't have the Solidcam tabs popping up.
Oh, it won't. You have to download the software.
Onto these computers.
Well, that's the problem, is we don't have any software. I was trying to work with the with Solidcam. I was trying to work with Solidcam.